In this project, we will be making a motor that uses magnetic fields and electric charges to cause a coil to spin. To make this motor, we used one battery, 2 paper clips, 1 rubber band, and some varnished magnet wire. So we used the battery as a source of electricity, the paper clips as conductors of electricity, the rubber band to hold the motor in place, and a wire to use as the thing that was going to spin that also had magnetic properties. So for the wire, we wrapped it around the battery because it was a pretty circular object, and one modification that we made was to make sure that the sanded side of the leg of the wire was touching the paper clip and aligning with the other leg's sanded side. As you can see, the coil points diagonally because the magnetic field causes an attraction of opposite poles. The magnetic field pushes the coil's south pole to the north and the north pole to the south, making the coil twist. The magnetic field's presence is indicated by the dark blue arrow. The magnetic field is present until the coil reaches the position modeled by the brown line. Once as the opposite poles align, the magnetic field is no longer present, causing the coil to complete the rotation. The magnetic field comes back when the alike poles align again. The magnetic field being turned off allows for the coil to spin. Once as the magnetic field makes the opposite poles align, the turning off of the field will make the position and direction of the coil change so that it drops to a position where alike poles align and the magnetic field is turned on once again. When it is turned on again, it will complete its half of the rotation.
The forces are balanced because the force of normal for the paperclip is equal to the force of gravity from the Earth. In this diagram, the forces are also balanced, but 2 forces of magnetism, one towards north and one towards south, cause the coil to spin.